These notes will go over lesson 4, which is average atomic mass. These notes can be found in your blue notes packet, so we'll write down the definition. We'll also talk through some examples, and I'll show you how to calculate average atomic mass. So before starting this, make sure you have your blue notes packet available. So just to give you an example of how what average atomic mass is like, if you had this jar of beads, you can clearly see that there's more pink and blue beads in the jar than there is green. So pink would be the most abundant bead in the sample. So if you pulled out a bead at random, the chances of you grabbing a pink bead would be much greater than the chance of you grabbing a green bead. So with that, if the pink beads had a greater mass, that is going to pull the average atomic mass up because there's more pink beads in the sample. So the average mass of the sample of one bead is going to be closer to the mass of one pink bead rather than the mass of a green bead, only because pink is more abundant. Another way you can think about average atomic mass and percent abundance is with quiz scores and class averages. So if you took a quiz and the class average was an 88%, we know that more students got an A or a high B on the quiz than a lower score. So because more students got a higher score, that's going to pull the class average up. So the average atomic mass is going to be skewed based on which element is most abundant. Just like our class average would be skewed based on which scores were most abundant. All right, in your notes, here's a definition for average atomic mass. Average atomic mass is the weighted average of all of that element's isotopes. So if you have 3 isotopes of carbon, it is going to be a weighted average of all those 3 isotopes. Here is the formula how to calculate. There's 3 steps. The first step is you take the percent abundance and you change it to a decimal. To change a percent to a decimal, you divide by 100, which is the same thing as moving the decimal 2 places to your left. The second step is to multiply the mass given in the problem by that percent abundance as a decimal for each isotope separately. Step 3 is to add all the masses together to give you your average atomic mass. So take a second, pause this if you need to finish writing down these directions. On the next slide, we'll go through an example, and hopefully these steps will make a little more sense once you see the numbers involved. All right, so here's an example. This example should be in your blue notes packet. Strontium is an element that has 4 isotopes. So here are the mass numbers for each individual isotope, and here's the percent abundance. So looking at the percent abundance, you can see that strontium-88 has the greatest abundance. So when we calculate the average atomic mass, we know the average mass is going to be closest to this 87.9 number, or at least pretty close, because that isotope is most abundant. So that is going to pull the average closer to that number. So again, from your previous slide, here are your 3 steps. First, we are going to change the percent abundance to a decimal. So I'm going to move the decimal 2 places to the left for each one of these. All right, so here's kind of a skeleton formula for each isotope separately. You take your mass times the abundance as a decimal. You do that for each isotope. So for this example, we would have 4 separate calculations. And in the end, you add them all together. Whoops, sorry, I have 2 addition signs. But once you get all 4, you add them together. So if we look at these numbers up here, our first isotope, I'm going to grab my pen, has a mass of 83.193. And that number we just get right up here. So you take your mass, and then you take it times your percent abundance as a decimal. So once we moved this decimal over 2 places, Now there's going to be 2 zeros after the decimal before you have this 5, 6. So that is where that number comes from. You're going to do the same thing for the second isotope. So that isotope has a mass of 85.909. And that percent abundance, once we change it to a decimal, would be 0.0986. We'll do the same thing for the third isotope, which has a mass of 86.908 and an abundance of 0.07. And then finally, we add our fourth isotope, which has a mass of 87.906 and an abundance of 0.8258. So once you have all of those values, you add them up. Once you add them up, you should get 87.613. Since these mass numbers just went to 3 decimal places, that's how we'll round our final answer. If you remember from your notes previously, AMU stands for atomic mass unit, which is how we measure the mass of an atom. So the mass of this isotope would be 87.613, which makes sense because this isotope with a mass of 87.906, this was most abundant. So we can expect our average to be closest to that number. If you were to calculate this value and you, for some reason, got an answer of 205, you know that the average of these masses cannot be 205. So always kind of do a double check to make sure that your number makes sense. The average of these values should be in between 83 and 87. So that's kind of a way for you to double check. So in your digital notebook, you'll do some more practice with this. It will not be on the quiz this weekend, but it will be on your test the following week. So I hope that helps. Let me know what questions you have.